I want to go back 40 years ago, September 1983. Korean Airlines Flight 007, it met a disaster. And that was a key moment for the GPS technology and the broader geospatial industry in context. Until September 1983, GPS was a classified technology. It was only used in military grade applications, and most of the technology, most of the concepts in traditional GIS built in the 1960s were built behind closed doors. That meant it did not integrate with the rest of the common technologies that the Mayer models used. And that has always created a barrier of bringing together those different concepts together. So when we talk about breaking the GIS data silo, as Javier was talking about, the two technologies, the traditional analytics data warehouse systems versus GIS systems, have remained largely separate for a multitude of reasons. Data warehouses, large monolith systems, really good at dealing with SQL processing, but they do not offer a lot of workload isolation. 4 years back, I built a COVID contact tracing solution using 30 terabytes of telco CDR data, combined it with healthcare data, and it ran beautifully. It was perfect. It was giving high accurate results. The DBA of the system was a friend. And he came to me and said, Fawad, I love you, but if your query takes more than 2% CPU, I will kill it. So that resource contention in those monolith systems, what does it force the GIS people to do? Let's get my personal post-GIS system, build it under the desk. It's tiny, it doesn't scale, but it's mine. And a data silo can never be cheap enough to justify its existence because of all the missed opportunities, the lack of integration across the enterprise that it creates. And that has always been a challenge. Then on the other side, those database systems, good at dealing with SQL-based processing and doing lots of interesting stuff with those types of data sets, but not so much on advanced, complex routing and GIS type of processing. So a few years back, I was working here with the retailer. They might be in this room. And they acquired a bank. And they came to me and they said, Fawad, we want to offer financial products to our most loyal customers. Okay, that's fine. What's your definition of loyalty? Well, they live close to our most #1 competitor, but they drive past our competitor to shop at our store. They are a loyal customer. So literally going the extra mile to shop at our store, not because we are close next door to them. The problem is most of the database systems, they only calculate crow flies between two lat longs. Give me 2 points, I'll draw a straight line, but in London, that straight line may be across the Thames. There will be a bridge, 20-mile-per-hour restriction. That 0.5 miles crow flies might be a 7.5 miles driving. Oh, you can do some PG routing and other kind of stuff, but only if the data is tiny. So how do I build that in? So on the other side of the fence, in GIS technologies, I was working with a very popular GIS system, and I tried connecting it to a database, and the tool gave me an error. I will not connect to a table with more than 250,000 rows. And I said, I thought we were dealing with big data here. So that's when you are working with offline cached copies, those are the challenges that are created. GeoAI is a unique intersection of technologies which is creating a lot of new opportunities. GenAI was the iPhone moment for analytics and AI in general. It is opening up opportunities that were previously missing. What Javier spoke about, from that evolution of number of users, let's be honest. GIS has always been limited to a bit of geeks, and there is a little bit of geek in all of us here. And what we are trying to do is, how do we democratize it and go to the masses? Could GeoAI, could GenAI become the sixth generation language? Could we democratize access to this data so that mere mortals can start querying this kind of complex systems? And if we are able to do that, the use cases across industries are unlimited. Whether you're talking with location planning, monetization, regulatory compliance, sustainability, better planet, you name it, and it is covered there. I'll pick on one of the particular use cases that I've been talking to a number of customers in the telecom network planning scenario, which is a quite complicated use case. Telecom companies have been hemorrhaging money for a very long time. There's always a new technology. There's always something that is around the corner. So there was first 1G, 2G, 3G, 4G, 5G. Companies haven't recovered their money from their 4G technology, and they're halfway through 5G rollout. And earlier this year, I was at Mobile World Congress in Barcelona, and they're talking about 6G. So what constantly happens? I need to figure out where do I install my next cell tower, where do I do my location planning, how do I do that? I need a lot of data to build in that. And in order to do that kind of analysis of traffic prediction and all the different kind of maintenance activities that are required, I need different kind of points of interest data. The problem with the points of interest data sets are they're inaccurate, inconsistent. Oh, the points of interest data shows a building. Oh, that building was demolished 6 years ago, but it still exists in the POI data. And that is a huge problem. So, because what I want to think about is the signal strength, and the people from the UK can appreciate how terrible the telco signals are. And what happens when you are on the top floor of the building versus in the basement versus in the tube. There are different considerations that take place when you are doing better planning for those kind of environments. And you need better access to such data. So what Snowflake does is we bring together all of these capabilities together into the Snowflake Data Cloud. We allow customers to run many types of complex workloads on a shared copy of the data, independent of each other on a pure consumption-based model. Whether it is AI, ML, applications, data engineering, and now GenAI, all of that runs in your own private, secure environment where it is tightly governed by your rules and access policies on the data. And on top of that, one of the biggest things that is coming up in this world is around collaboration between the different value chain partners. If there are 2 Snowflake accounts and you want to share data between 100 terabytes of data between 2 Snowflake accounts, it is done in 1 second because it does not create a copy of the data. And it creates unique opportunities, and that creates this dynamic network effect across the entire ecosystem of sharing the data. These are Snowflake customers sharing the data with each other and building and enriching each other's data sets, whether it is for sustainability use cases, for scope 3 emissions, whether it is for getting better insights and building better data products for each other, monetization, regulatory compliance, and much, much more. And all of that within the security parameters of their own account. Now, talking about the GenAI side of things, In Snowflake, we have this capability called Cortex, through which we simplify access to the GenAI model literally like a simple SQL function. It's a user function that you call, and underneath those functions, you can run many types of models. You can take open source models like Llama and Mistral. You can have many different types of multimodal models, like Rika and Snowflake released our own model called Arctic a few weeks back, and you can get into other commercial models as well. You want to fine-tune your own model, there is another option for you. So you want a ready-to-eat GenAI model on a pure consumption-based pricing model, you can get that from Snowflake. And the thing what Javier was talking about, that AI agent that is sending those images and different information to the model and getting information on that, you can build that using this Snowflake ecosystem. And we have, in the telecom domain, we have customers who are combining their GIS data with other data sets. And an example of that is taking call center transcription, call center logs, MP3, MP4 audio, transcribing them into natural language, running LLM models on top of it, and then combining it with the rest of the ecosystem to do what kind of location planning I can do based on the customer complaints. Now, there's one very important thing in this equation, because while GenAI is great, one question customers are asking, are you going to use my data to train your models and do something else? In the case of Snowflake, your data remains private, your metadata remains private, your models remain private, your prompts remain private. Because think of those call center transcription records. They have a lot of sensitive information. Customers are describing their context and all those information, and you don't want to give it to any public model which could be using that information for different purposes. And that means their possibilities to build different types of advanced capabilities are endless. And we are taking this in the customer service domain by taking that location planning and all. We are working with a telco customer on what we are calling it customer intent prediction. When the caller calls the call center, we'll predict what is the likely reason the caller has called, the top 3 reasons. And we save on the call center cost and optimizing it. And the natural question is, if you already know what the problem is, why don't you fix it? Why do you need a human being at the end of it to fix the problem? So that is going to be the next phase. This is the degree of what in telecom domain we call the autonomous networks. How do we get to that level of automation? If I have all the collection of the data from core network and CRM, ERP systems, I have the total customer 360 view in my business, I can then figure out why the customer is calling and what is the issue and how can I automatically fix it. And this is all done through the combination of all the geo and non-geo data into the Snowflake ecosystem. We have several native geospatial capabilities in Snowflake with native functionalities, grid systems, H3 support, and a very enhanced marketplace which has a lot of points of interest data sets on spatial and non-spatial, and then also allowing you to build advanced native applications such as routing, geocoding, and much, much more. And this is what Snowflake and Carto together, what we are doing, we're combining all of these capabilities together, bringing that GeoAI to scale, simplifying access, making it simpler, making it accessible so that even those non-GIS people can start making use of those geo capabilities as features in their own models. So it's not just restricted to those GIS people who were running those systems under their desk for many, many years. We have lots of different integrations inside the Carto Snowflake combination. We have got the Carto Analytics Toolbox, which enriches the Snowflake library on geospatial, the Carto platform, the routing engine for fleet optimization. It basically converts Snowflake into a scalable TomTom. You want to do millions of route calculations, you can run that right inside your account, keeping the data private, and building all of that into the ecosystem. And then Javier also mentioned about Overture Maps. I mean, this is unbelievable data set available to all of you for free. It will make sure that you will have the data set about those buildings, places, road networks at your fingertips without doing any kind of ETL, accessible to you right within your account there and then. And then taking it to next level, combining different rasters and vectors together, right? So talking about in the telecom domain, you have got a lot of raster data with regards to RF coverage, the radio coverage across the network. I want to get that data. I want to understand what does the radio signal look like in different parts of the country, and how can I bring different capabilities of both vector data from internal systems, from external systems, from collaboration, from marketplace, the points of interest, and then getting those raster data sets all into the ecosystem, building that full view of my business to provide real-time insights and make accurate business planning decisions. We have customers in the telecom domain and others who are using the solution together, building it out, and running processing at the scale unheard of in the traditional GIS domain. We have a customer who is processing 15 trillion ST points in Snowflake in 4 minutes. And just in case we forget how big is a trillion, I always remind people, 1,000,000 seconds is 11 days, 1,000,000,000 seconds is 31 years, 1,000,000,000,000 seconds is 31,000 years. And that's, remember, the traditional GIS tool was complaining on 250,000 rows. So what we are talking about is, let's combine these two technologies without any compromise, bring it to scale, and do things which were previously unthinkable and unheard of. The possibilities are only limited by your imagination. Like Javier said, our goal is to democratize access to these GeoAI capabilities, because the fundamental laws of economics says, if you make something cheap and convenient, it's only a matter of time before it becomes ubiquitous. Thank you so much.